Before we get to color and natural selection, this lesson does do a review of correlation and causation, which I think is a really important concept in science. So correlation is when there's a relationship between two sets of variables in which one variable responds to changes in the other. So you can have positive correlations. So things like as a child gets older, their clothing size increases. So both things are going up. Age is going up, clothing sizes increases. As temperature rises, ice cream consumption increases, right? Both things are increasing. So that's a positive correlation when they're both moving in the same direction. A negative correlation is when one goes up and the other decreases. So a negative correlation is like an older a man gets, the less hair he has. So he's getting older, but he has less hair. So one thing's going up, age is going up, the amount of hair is going down. That was a funny one I found online. So again, correlations can be positive or negative, going up together, or one going up, one going down, or going down together. That could also be a positive. All right, now causation is when an observed event or action makes another thing happen. So it's when that correlation, that those two variables, one is causing the other, right? So causation is when one thing, changing one thing, causes another thing to happen. Now, this is a big thing in science. Correlation does not mean causation. Just because two things correlate, just because there seems to be a relationship, does not mean one is causing the other. Your lesson gives the example of ice cream and snake bites, that as we see people increasing their ice cream consumption, we see an increase in snake bites. So does eating ice cream cause snake bites? That doesn't make any sense. And if you think about it and redo some other research, you find out, oh, another thing that's happening is temperature is rising. So people are eating ice cream because of the temperature. Snakes are more active because temperature is rising, and so now they're more active and out there, and people are getting bit more often. But the ice cream part is not causing the snake part. Okay. Another one of my favorite examples of correlation does not equal causation comes from the Flying Spaghetti Monster, which is this spoof religion. And they, under their umbrella, they argue that global warming is caused by a decrease in pirates. So they have this campaign like, become a pirate, stop global warming. But there's a negative correlation between the number of pirates. So this graph here is actually decreasing. These numbers are decreasing. So as time, and here we've got different dates, as time increased, we've got less pirates out there. But global temperature has increased during that time. So again, correlation does not equal causation. You can think about like the MMR vaccine and autism. There does seem to be a correlation with getting that MMR shot and developing autism. And unfortunately, there was a study done a while ago where a guy did test that, and he made up his data, and it looked like it was actually causation. But with further research and studies and other people trying to replicate his results, it turned out that he fabricated his data and it was all fake. But that's just another example in society where correlation does not mean causation. That shot is not causing autism to develop. But an example in science where we have to really think about, and analyze and critically think. Now, controlled experiments are what we can do to help see, are these correlated variables, is it one causing the other? So we can do controlled experiments to determine causation. With a controlled experiment, you change one variable and see if it produces a change in another. In a recent lesson, this unit, we reviewed the terms independent variable, the thing that you're changing, the thing that you're manipulating. You expect that to have a change in the dependent variable. This will be the thing that you're measuring and recording, right? And if caffeine does, have an influence or a causation on the number of words recalled, then you would see that in your experiment. Now, in an experiment, remember, we have control variables. You control everything else and make sure nothing else is different, nothing else that could affect that dependent variable. So that way, at the end of the experiment, you can say it was because of the thing that we changed. So in this example of changing caffeine and seeing if that affects the number of words recalled, you want to do the test at the same time for everybody. You want to make sure that they haven't had any caffeine, in a long period before, and you want to make sure it's a quiet environment. These are just a few of the things that you want to control to make sure the results are because of the thing that you changed. All right, so that was just a review on some experimental setup and correlation and causation. Always good to review that. But getting to what the title is and another part of the lesson, skin color and natural selection. So our skin color in the past has been under the influence of natural selection, and that has created the different skin colors that we see today. Now, all of us in our cells, in our bodies, in our skin, have cells called melanocytes. And melanocytes produce a pigment called melanin. And we each have different variations on how much melanin we produce. And melanin is the pigment that gives our skin color. So somebody who is darker skinned produces a lot of melanin compared to someone like me who's pretty light skinned. I don't produce a lot of melanin. But that's really the only thing that makes our skin different color, is how much melanin you produce. Now, melanin is a natural protectant against UV radiation. So it's kind of like a natural sunscreen. So it protects our skin from getting sunburned. So even if you're dark skinned, if you're out in the sun too long, you can still get sunburned, just not as easily as someone with lighter skin. Now, if you look at the color of indigenous people throughout the world, you see an interesting pattern. You see in countries along the equator here, you see people tend to have darker skin. Okay, as you move away from the equator, skin tone gets lighter and lighter. Right, again, this is a map of indigenous people, so people who are native to those regions. And obviously now, in today's world, people live all over the place, and but this is from way back when. One of the hypotheses to explain this pattern that you see is called the vitamin D folate hypothesis. It's just one of the hypotheses, and your lesson doesn't point out that there are other hypotheses out there of why this pattern occurs. But one of them has to do with vitamin D and folate. So vitamin D is a vitamin in our body that gets created with UV light, and it helps people absorb calcium in their bones, among other things. It does lots of different things, but one of the big things it does is help calcium get into our bones, so we have strong bones. If you don't have enough calcium, then you have brittle bones and they break easily. And back in the times of this map, you would have, if you didn't have enough vitamin D, then you might break a bone and not survive and not be able to reproduce. All right, folate is another mineral or micronutrient in our body, and one of the big things it does is it helps fetal development. It helps the neurosystem of a fetus develop. And today, if women are pregnant, you're encouraged to take a supplement that includes folate to decrease your chances of spina bifida, which is a condition where the spinal cord does not completely fuse in the baby. All right, both of these are under the influence of UV light. and they have different reactions and things that happen to them. So for folate, UV light degrades folate, so it breaks it down and makes it so you don't have as much. And vitamin D, UV light produces vitamin D. So you need UV light to make that vitamin D and have the strong bones. Now at the equator, you have a lot of UV light. Okay, as you move away, and that's why, you know, at the equator you have very tropical temperatures. It's warm all the time. And then as you move away from the equator towards the poles, it gets more temperate. So you have more seasons, right? Sometimes it's cold, sometimes it's hot. And then, you know, you can have at the poles even more extreme seasons, like in Alaska, it's dark half of the year and then it's light half the year, right? But at the equator, we see there's a lot of UV light. So there's an advantage for people having dark skin to protect from the UV light. They're still getting tons of UV light, so they're you know, producing enough vitamin D, and they're protected against folate. But as people moved away from the equator, and people originated, Homo sapiens originated in Africa with dark skin. But as people moved away from the equator, they had less UV light, and with the dark skin, were not able to produce as much vitamin D. So, you know, through time and mutations that naturally arise, some people had mutations or inherited mutations that decreased the amount of melanin that they produced. So then they were able to make more vitamin D, have a higher fitness, have, you know, be able to survive and reproduce and pass on that trait. And those mutations continue to, you know, be selected for as you moved away from the equator. Again, you know, as you move away from the equator, you have less UV light, and it was advantageous not to have dark skin, so that way you can get enough vitamin D. But there had to be a balance between, you know, the UV light degrading folate and breaking down folate, but it's probably not as intense, and further away, it's not breaking it down as much, but you need that vitamin D. So that is how the hypothesis works. Again, it's one of the ideas of to explain, and it does have a lot of evidence to help explain why you see that pattern of skin color on the planet. All right, this lesson also brings up peppered moths again at the end. We learned about this in a previous lesson. These are moths that live in, that you find in England. They live on this birch tree, so when they're peppered color, they blend right in. But they do have a mutation that produces a dark color moth, but the dark color ones stick out, so they don't tend to survive and reproduce because they get eaten by predators. At this point, I need to give you the code word. The code word for this video is going to be coffee. The code word for this video is coffee. Now, with the pepper moth story, in the early 1800s, there was the Industrial Revolution. So, there's more industry, more burning of coal. So a lot of soot gets into the atmosphere and was landing on these white trees and causing them to be dark. And so the environment was changing, and the trait that has the advantage is also changing. So now the individuals with the darker color, the mutated pigment gene, they have the advantage because they blend in. The peppered guy, the white peppered guy, sticks out like a sore thumb and is getting eaten up. And they do, they have numbers and documentation of the peppered moths, the white color decreasing and having almost completely dark colored populations, again, due to natural selection. And what's interesting is, several years, I don't know how many years later, in the 1900s, we started to care about air quality, started putting more regulations to decrease the amount of soot that got into the atmosphere, and the tree color, that soot went away, and with rain it washes it off. So eventually the trees started to be white again, and the white peppered moth coloration came back. Pretty cool example of natural selection. Now, your quick check has a question about the peppered moths population, and it's asking which one caused it to increase in the late 1800s, the dark color. Well, the color, what was happening and the environment changing isn't an option. So when you look through the options, think which one would cause any organism to increase in size. Which one of these, it has nothing to do with the pepper moth story. Which one of those things, or the time of year or time in history, which one of those things would change? Oh, I forgot to put a star on this slide. Which one of those things would put a change or allow any organism anywhere at any time increase in number?